Have you ever wondered if you can drive a car in space? A curious question, isn't it? It's the perfect blend of everyday life and the extraordinary world beyond our planet. Today, we'll attempt to answer this intriguing query. We'll explore the vastness of space, decode the physics of driving, understand the mechanics of a car, and even propose some theoretical solutions. It's going to be a cosmic journey, indeed. So let's dive into the physics of driving a car in space. To understand why driving a car in space is not as simple as it sounds, first, we need to understand space itself. Space, the final frontier, is a mystery that continues to captivate us. It's an expanse of almost nothingness, a vacuum where molecules are so few and far between, making it a stark contrast to the dense atmosphere we're accustomed to on Earth. This lack of atmosphere means there's no air to carry sound, no wind to feel on your face, and no air resistance to slow objects down. Imagine trying to drive a car in such a void. Then there's the issue of gravity, or rather the lack thereof. We're so used to Earth's gravity that we often forget how crucial it is for everyday activities. In space, there's only microgravity, a state of very weak gravity. This would make things quite tricky for a regular car. Without gravity, the car wouldn't stay on any surface, and without a surface to push off from, the wheels would simply spin in place. Moreover, a car's internal combustion engine needs oxygen to function. Guess what's missing in space? That's right, there's no oxygen. This means, in its current form, a car wouldn't be able to generate the combustion needed for propulsion. Now that we have a basic understanding of space, let's see how a car would function in it. In order to drive, a car needs to push against something. Let's delve into the basic physics of driving here on Earth. When you press on the gas pedal, your car's engine generates power, which turns the wheels. But it's not just the turning of the wheels that gets you moving. You see, your tires need to grip the road to create a force that propels your vehicle forward. This is where friction and traction come into play. Friction is the resistance that one surface encounters when moving over another. In the context of driving, it's the friction between your car's tires and the road that allows your vehicle to move without slipping. Traction, on the other hand, is the grip between the tire and the road surface. The more traction your car has, the better it can accelerate, turn corners and stop when you apply the brakes. Now let's contrast this with the conditions in space. Space is a vacuum, meaning it's devoid of air or atmosphere, and more importantly for our discussion, it lacks surfaces to drive on. So, in the absence of a road or any other surface, there's nothing for a car's tires to push against. Furthermore, without an atmosphere, there's no air resistance or drag, which on Earth helps slow down a car when the brakes are applied. In space, even if you could get your car moving, without air resistance, it would just keep going at the same speed and in the same direction until acted upon by another force, thanks to Newton's first law of motion. This makes the concept of driving as we know it pretty impossible in space. The wheels of your car could spin as much as they want, but without that all-important friction and traction, there's nothing to convert that spinning into forward or any motion. So without something to push against, a car in space would simply float around. But what about the mechanics of the car itself? How would they function in space? Well, let's take a step-by-step look at this fascinating thought experiment. First up, the engine. Most cars on Earth run on internal combustion engines which require oxygen to burn fuel. In the vacuum of space, devoid of oxygen, this type of engine would simply not work. There's no air to feed the fire, so to speak. Then we have the issue of heat. Here on Earth, cars dissipate heat into the surrounding air. In space, there's no air to absorb this heat. This would lead to a rapid overheating of the engine, causing serious damage. Moving on to the tires. Most car tires are filled with air under pressure. In the vacuum of space, the lack of external pressure could cause these tires to expand and potentially burst. Not to mention, tires wouldn't have any traction because there's no ground to grip onto in space. Now let's consider the car's battery. Batteries generate power through chemical reactions, and some of these reactions could be affected by the extreme temperatures in space. It's possible that a car battery would drain faster or not work at all. The car's cooling system presents yet another problem. Coolant, which absorbs heat from the engine and dissipates it through the radiator, wouldn't function properly in space. Without air to cool the radiator, the coolant would just keep getting hotter, exacerbating the overheating issue. Lastly, we have the issue of lubrication. Many car parts need oil or other lubricants to function smoothly. In space, these lubricants could boil off, causing parts to grind together and wear out quickly. So, as we delve into the mechanics of a car operating in space, it becomes clear that our earthly vehicles are not designed for such an environment. They rely heavily on the presence of air and the Earth's atmospheric pressure to function. As we can see, a car as we know it would not function properly in space. But let's not give up yet. Are there any theoretical solutions to these problems? Well, one potential solution could be to use rockets for propulsion. Instead of relying on the friction between the tires and the road to move forward, a space car could use the principle of action and reaction. This is the same principle that rockets use to move in space. The rocket propels gas out of its back end, and the reaction pushes the rocket forward. In the same way, a space car could propel gas out of its back end to move forward. However, this solution has its own set of challenges. For one, it would require a constant supply of gas, which is not practical for long journeys. Another potential solution could be to design cars specifically for space. These space cars could have features that regular cars don't have, like thrusters for movement and rotation, and a power source that doesn't rely on oxygen. They could also be designed to withstand the harsh conditions of space, like extreme temperatures and radiation. However, designing and building such a car would be extremely complex and costly. It would require advances in technology and materials that we don't currently have. There's also the possibility of using magnetic fields for propulsion. Some scientists have suggested that a car could generate a magnetic field that interacts with the magnetic field of a planet or moon, allowing the car to move. However, this solution also has its challenges. For one, it would only work on celestial bodies with a strong magnetic field. For another, it would require a power source that can generate a strong magnetic field, which is not currently feasible. In conclusion, while these solutions are theoretically possible, they are far from practical. They all require significant advances in technology and resources, and even then, they would only work under specific conditions. So, for now, the idea of driving a car in space remains just that, an idea. While these solutions are theoretically possible, they are far from practical. So, can you drive a car in space? Let's take a moment to reflect on our cosmic journey, as we've delved into the mysteries of space and the physics of driving. We've learned that space, far from the terrestrial environment we're used to, is a vacuum, devoid of air, and filled with microgravity. This lack of air means that the internal combustion engine we're familiar with in our earthbound vehicles wouldn't function as there's no oxygen to support combustion. The absence of gravity, on the other hand, would render the wheels of a car useless, as they wouldn't be able to grip onto anything to propel the vehicle forward. We've also examined the physics of driving, and how it fundamentally changes in the vacuum of space. On Earth, a car moves forward by the wheels, pushing against the ground, an action that relies on the force of gravity. In space, however, Newton's third law of motion comes into play. For every action, there's an equal and opposite reaction. In the vacuum of space, any force exerted by a car would result in the vehicle moving in the opposite direction. Additionally, we delved into the mechanics of a car in space. Our exploration revealed that without modifications, a standard car wouldn't be able to function in space. The lack of air pressure could cause the fluids in a car, like fuel and lubricants, to boil away. The extreme temperatures would also pose a challenge, potentially causing parts of the car to warp or crack. But we didn't stop at the problems. We also brainstormed some theoretical solutions, like creating a car with a self-contained oxygen supply for combustion, or perhaps using electric propulsion. We even thought about a car with magnetic wheels for hypothetical space highways. While it's a fascinating thought, current technology and physics tell us that you can't drive a car in space as you would on Earth. But who knows what the future holds? Maybe one day, we'll have space highways filled with space cars.